Okay, ladies and gentlemen of algebra, this is Unit 6, Notes 2. This is called exponential growth. And an exponential growth is kind of exactly what it sounds like, is guaranteed growth. Now, you've already talked a little bit about the exponential function. So exponential growth is just looking at about half of that. It's just looking at the graphs that kind of increase and kind of looking at situations where that might happen. So your learning target, you need to be able to graph, model, and apply exponential growth functions. So you need to be able to sketch a graph. You need to be able to look at and model some information that might be exponential. And you need to be able to apply what that function might look like. So here is kind of what an exponential growth function will look like. So here's kind of the way it breaks down. C is going to be your initial amount. All right. The rate of change is going to be your percent. That's going to be your R, and T is going to be your time. Now your time could be in years, it could be in months, it could be in minutes, it could be in seconds. You're going to have to look at the problem and determine what you're looking for. Okay, now your C value is also your Y-intercept. So it's kind of what happens at time 0. Well, time 0 is when this little experiment will start, and then so that's going to be your initial starting point. All right, so if we take a look at here, C is 8 and R is 0.45. So you're looking at 8, 1 plus 0.45 as a function of time. So 45, that's written as a decimal. It would be 45% as a percent. So at time 0, 1, 2, 3, 4. So at time 0, that's just going to be 8. All right, that's because if I take 8 and the 1.45 raised to the 0, well, anything raised to the 0 is 1, so that's saying take 8 times 1, and that's just going to be 8. For 1, that's saying take 8 times 1.45 raised to the first. So 8 times 1.45 raised to the first is going to be 11.6. So now as I go along here, I'm going to take 1.45 squared, and that's going to multiply that by 8. So that's going to be 8 times 2.1025. So that's going to be 16.82. So then I'm going to take 8 times 1.45 cubed. And that's going to be 24.389. Then if I do it one more time, I get 35.36405. So if, wherever I start, well, I start here at 8. At 0, I'm at 8. At 1, I'm at 11.6. So that looks to be right about there. At 2, I'm at 16.82. So that looks to be about right here. And after that, I'm off the graph. So my sketch basically just looks like that. That is what my exponential growth function will sketch like. So if C is 6 and R is 1/3, well, 1/3 you got to realize that's not as a decimal. Well, 1/3 as a decimal is going to be 0.3 repeating, or just 0.33. So when I set this up, it's going to be 1 plus 0.33 as a matter of time. So it can't be exact, but we're going to get as close as we can get. So at 0, 1, 2, 3, 4, this is my function. Okay, initial amount, my rate R, and then this is my function time. So at time 0, just like before, I just go with C. So that's going to be 6. 1 is going to be 6. 1 plus 0.33 times T. Well, T is going to be 1. So I'm going to take 1.33 times 6. That's going to give me 7.98. Now I'm going to multiply it. Now I'm going to square it. So 1.33 squared times 6 is going to be 10.6134. Here's a common mistake that kids see. They'll do this. And say it's just raised to the first power. So here's what I'll see kids do. They'll add it here. I don't know why I wrote that. 1.33 raised to the 1, or raised to the, let's do squared. they'll raise this squared. So now I'll see this, 6 times 1.33, and then square that. That's not what we want to have happen. No, you've got to follow order of operations and do this part first. So you've got to follow your exponents first. So like for this next one, 1.33 cubed goes first, multiplied by 6, 14.11. So then this is going to be 18.77. So now when I go to graph this, I start off at 6 because that's what C is. At 1, I'm only at 7.98, so I'm really close to 8, but I'm not there. At 2, I'm at 10.6, like there. At 4, I'm at 14.11, right here. And 4, wait, at 3, I'm sorry, I skipped 3. It's 3, I'm at 14.11. And at 4, I'm at 18.77, so I'm right there. So this is going to look like that. That's what that's going to look like. So let's take a look at a word problem here. 1971, there were 294,105 females in high school sports. Since then, the number has increased at an average rate of 8.5% per year. Write an equation to represent the number of females participating in high school sports since 1971. So 8.5% converted to a decimal. Decimal just means I move it over 2 places. So my R is going to be that. Okay, so this is going to be my rate. My initial amount, my C, is going to be 294,105. So this is going to look like 294,105 times 1 plus 0.085 times T. So according to the equation that you wrote, how many females participated in sports in 2005? All right, so my initial time was 1971. So it's 1971, that's time 0. Okay, so how many years was it to 2005? Well, simple way is just subtract them. And that's going to be 34 years. So what I want to do is take 294,105, 1.085 raised to the 34. So 1.085 raised to the 34th times 294,105. So how many females are participating? 4,711,004.36 females. So rounded to go 4.7 million, 4,711,004. So in 2010, the state of Farmington had a population of 21,087 and a growth rate of 1.9%. Write an equation to represent the population of Farmington since 2010. So 2010, that's my time 0. Here is my initial amount, that's C. There's my growth rate, but I need it as a decimal, so that's going to be 0.019. So that's going to be just equal to 21,087, 1 plus 0.019 raised to the power of T. T would be your time. In this case, would be in years, per year. They kind of tell that to you in the beginning. So what would be the approximate population of Farmington 2013? How about 2017? So 2013, from 2010 to 2013, that's a span of 3 years. So that's just going to be 21,087 times 1.019 raised to 3. This is going to be 21,087, 1.019 raised to, instead of 2017, that's just going to be 7 years. So 1.019 raised to the third times 21,087. So that's going to be 22,311.94. So you can round up. So that's going to be 22,312 people. And then for this one, 1.019 raised to the seventh times 21,087. So this is going to be 24,056. So those are going to be your kind of your guessing increases there. So compound interest. Interest is something that is very important, especially when you go to buy cars, buy houses, buy anything long term. You're going to need to get probably a loan, and a loan has interest. That means it's the more money you pay back. So your A is your ending amount. P stands for principal. It's the amount of money that you're probably going to borrow. Interest rate is your I, or your R, sorry. N is the number of times it's going to be compounded per year, and T is the number of years. So compounded means how many times they're actually going to calculate it. So daily, 365, it's just 365 days in a year. We don't count leap years. Weekly, 52 weeks. Monthly, 12. Quarterly, 4. Semi-annually is 2. Annually is going to be 1. All right, so make sure you kind of keep that straight. Quarterly, obviously, it's just divided by 4, so quarters. Monthly, there's 12 months a year. Semi-annually is going to be twice a year. So Maria's parents invested $14,000 at 6% per year, compounded monthly. How much money will there be in 10 years? So your principal is going to be $14,000. The rate as a decimal is going to be 0.06. All right, it's compounded monthly. All right, so the number of times is going to be 12 per year, and your time is going to be 10 years. So let's go back, take a look. So we've got P, we've got R, we've got N, we've got raised to the N times T. So my principal amount is 14,000. And this is going to be 1 plus, what did it say? 1 plus the rate, which is 0.06, divided by how many times they do it per year, all raised to the number of times they do it per year times the years. Okay, so this becomes 14,000 times 1 plus, let's see, 0.06 divided by 12. It's going to be 0.005. And all I did was take this and then add it on, raised to the 120th power. So 1.005 raised to the 120th times 14,000. So after 10 years, there's $25,000 in there that can be used for whatever purpose. So determine the amount of investment of $300 invested in an interest rate of 3.5%, compounded semi-annually for 22 years. So what's important? 300, interest rate 3.5%, semi-annually, 22 years. All right, so my principal is going to be 300 bucks. The rate is going to be as a decimal, 0.035. The number of times it's compounded is going to be semi-annually, so that's 2. Time is going to be 22 years. So my principal amount, 300. My rate, 0.035, compounded twice a year, raised to the 2 times 22. So when I do that, I end up with 0.0175 raised to the 44th power. So when I multiply all this together, and I'm letting the calculator do a lot of this legwork for me, that's going to be my dollar amount. That's going to be my finishing amount when I do that. All right. Happy students use their time wisely. So if you have questions with this, need to borrow a calculator, come talk to me. Otherwise, your iPad should suffice. Work hard and play around with this and see what you can